Hi everyone, today we will discuss a medium hard level binary tree problem. LeetCode algorithm problem 99, recover binary search tree. Firstly, let's see the description of this problem. You are given the root of a binary search tree, where the values of exactly two nodes of the tree were swapped by mistake. Recover the tree without changing its structure. Okay, let's see how to solve this problem. Firstly, let's see a similar problem. How to find two swap numbers in an ascending array. Let's see. In the ascending order array 1, 2, 3, 4, 5, if we swap 2 and 5, it will become a new array 1, 5, 3, 4, 2. So how can we find the swap numbers 5 and 2 in the new array? Firstly, let's traverse the new array. So the first number is 1, and then the second number is 5. Now the order is ascending, and then from 5 to 3, the order is descending. So we will find the first one number here, 5, in the descending order. And now we actually traverse to the third number 3, and the previous number 5 will be the first swap number. Okay, let's continue. So after 3, the number is 4, and the order is still ascending. And after 4, from 4 to 2, the order becomes descending again. And we find the second swap number 2. However, in this time, 2 will be the current number in the traversal. So we can find the swap numbers when descending order appear. And in the first descending order appear, we will find the swap number from the previous number in the traversal. And when the descending order happens again, we will find the second swapped number for the current number in the traversal. Okay. Actually, in a similar way, we will find the swapped nodes in the binary tree. Then we will discuss how to traverse this binary search tree. Actually, we need to use in-order traversal, because in in-order traversal, we firstly traverse the left subtree of the current node, and then we visit the current node, and then we visit the right subtree of the current node. And in binary search tree, nodes in left subtree will be smaller than current node, and the current node will be smaller than the nodes in right subtree. So if we use in-order traversal, the value of the traversed nodes will be in ascending number except for the two swapped nodes. And then we can use the similar way to find the swapped nodes and recover the binary search tree. Okay, let's see. Then let's see the code of the in-order traversal recursion function. We define 3 global variables: swap node 1, swap node 2, and prime node. We store the first swap node in the global variable swap node 1, and we store the second swapped node in the swap node 2, and we store the previous node in the traversal in prime node. Firstly, we consider the corner case. If current node is none, we just return the recursion function. And then we traverse the nodes. Because we use the in-order traversal, we firstly need to traverse the left subtree of the current node. That's why we use the in-order traversal and pass the left node left child node to it, and then we process the current node, and after that we traverse the right subtree. Okay, let's see the process of the current node. So if the previous node is not null and the value of the current node is smaller than the previous node, which means the descending order appears and we will find the swamped nodes. Okay, so we pass the current node to swamp node 2, and if the swamp node 1 is null, which means the descending order appears for the first time, because in the initialization, the swamp node 1 and swamp node 2, both of them will be null. So if swamp node 1 is null, which means the descending order firstly appears. And as we see here, the descending order firstly appears, the previous number will be the first swamped number. So here, we will pass the previous node to the swamped node 1. And as we see here, for the second descending order happens, the current number will be in the second swamp number. Okay, so similarly, if swamp node 1 is not null, which means it already stores the first swamp node, actually the bigger swamp node, and in this case, if the swamp node 1 is not null, we actually know the descending order happened for the second time. So for the second time, the current number will be in the second swamped number. And similarly here, for descending order happens for the second time, the current node here will be in the second swamped node. So for the swamp node 1 is not null, the second swamp node is just the current node, so we just need to return, because we already passed the current node to the swamp node 2. In this way, we will find the two swamp numbers, and they are stored in the swamp node 1 and the swamp node 2. Here, we pass the current node to the price node, and in this way, the current node will be in the previous node in the next iteration, and we can update the price node one by one, and the price node will always store the previous node in the traversal. In this way, we finish the coding for the in-order traversal. And here is our initialization, and then this is our recursion function. We firstly pass the root to it, and then deal the traversal and the finding swamped nodes by recursive iterations. And after the recursion function, we will find the two swamped nodes and store them in the swamp node 1 and swamp node 2 here. And here we can see we have the swamp node 2 value and pass the value to the swamp node 1. Here we pass the swamp node 1's value to the swamp node 2. In this way, we just swamp the these two nodes, and then we recover the binary search tree. Because in the recursion function, we actually traverse the whole tree once, so the time complexity is O(n), and due to the recursion, we need to store the nodes in stack, so the space complexity is also O(n). Okay, we just finished our coding, and we submit our solution. Yeah, it succeeds. So we will finish our discussion today. Thank you so much for your watch. Bye bye.